Greetings and welcome to the Data Armory. Welcome to another part of statistics for data analysis. And as we had seen in the first part, is that many people who enter the data analysis field, they always ask that how much statistics do I need to know? And we have been in the journey of answering that question by at least giving you a roadmap of the statistics that you need to know for data analysis. And if you remember, in our first video, which we'll link down in the description below, we talked about structured data, or rather, when you look at the mind map that we were using when we're talking about exploratory data analysis, we gave a roadmap of the essential statistical concepts that a data analyst should know when it comes to statistics for data analysis. And we said that statistics is broad, but at least there are basic concepts that a beginner is supposed to know. And we talked about structured data. We talked about structured data. And when we talked about structured data, in the very first node of this mind map, we talked about data types. So today we are going to break down what structured data is and at least explore more of this first node, which talks about data types. So in this tutorial, what are we going to do? We will download the Olympics dataset, which we will utilize to provide practical code examples. We will also define structured and unstructured data. And maybe someone might ask why define structured and unstructured data. We'll answer that in the tutorial. We'll also delve into the fundamental classifications of structured data, which are namely numerical and categorical types. So delve into the fundamental classification of structured data, namely numerical and categorical types. Then we look at the preferred methods for visualizing structured data. Now, the reason why this tutorial is important for data analysis beginners is that you'll get that a major challenge in the data analysis field, or in the data science field if you like, is to harness raw data into actionable information. And to apply the statistical concepts covered, statistical concepts, unstructured raw data must always be processed and manipulated into structured form. So these are challenges that you'll meet every other time, whereby to apply statistical concepts, you will always need to convert unstructured raw data into structured form. So that is the importance of this tutorial, where we'll be looking at structured and unstructured data. Before we get into practical examples, let us revisit our mind map. Let us revisit our mind map that we used last time. So in the mind map that we used, this is the roadmap that we gave. That when we're doing exploratory data analysis, is important to understand what structured data is, and we talked about data types. So we'll dig deep into this and now break it down. You see this node. We'll now break it down as we look at structured and unstructured data. So when we talk about structured and unstructured data, at least it has dawned on you that when we talk about data, it can be divided into structured data, unstructured data, structured data, and semi-structured data. So when you are studying statistics for data analysis, at least you need to have a clue when it comes to what unstructured data is, what structured data is, and what semi-structured data is. At least you need to know this in your statistics for data analysis, and more so when you're dealing with structured and unstructured data. So when you're studying structured and unstructured data, at least you should know what unstructured data is, what structured data is, and what semi-structured data is. When we talk about unstructured data, an example of unstructured data are text, images, audio, and videos. And as we have already mentioned, that the major challenge that you'll be met with is to change or rather to manipulate this unstructured data into structured data or into actionable structured data. So unstructured data, when we talk about unstructured data, we talk about text, images, audio, and video files. And I know that you've interacted a lot with this. So those are the examples of unstructured data. Now, when we talk about structured data, it is divided into two. Structured data is divided. It's the broad categories, or the two basic types of structured data are numeric and categorical. And you'll see that we spend a lot of time on structured data, because in the data analysis field, in as much as you know what unstructured data is, the biggest challenge, as we have said, or the biggest part of data analysis will be to manipulate these unstructured data into structured data that can be into actionable structured data. Also, when we talk about data types, or structured and unstructured data, there is also semi-structured data. And an example of semi-structured data is a CSV file. So you also need to understand semi-structured data, and an example of semi-structured data is a CSV file. And you can go and find out what a CSV file is. That is an early assignment into this tutorial. Go and find out what a CSV file is, and always remember, Google is your friend. At least you have a clue when it comes to what a CSV file is. So we have said that much of this tutorial we are going to highlight on structured data, because we have already given examples of what unstructured data is, what semi-structured data is, and now let us delve a little bit more into what structured data is, because that is very important. Because as a data analyst, you'll spend a lot of time working with structured data. So the examples that we are going to give, we are going to use an Olympics data set. Going to use an Olympics data set, and we are using a Python programming language, and we are using the Pandas library. And even if you are not using Python programming language or Pandas library, at least these basic concepts are important when it comes to data analysis, whichever tool you are using, or whichever library or language you are using. So we'll use the Olympics dataset to give practical examples, because as we had said, we are going to give practical examples. Now we will download the dataset, and we have a tutorial on how to download datasets from Kaggle into your local machine or local working environment. So we'll also link the tutorial in the description section below. So we'll download the dataset, and we'll not go much into this because we have a full tutorial on this. So you can go and check it out. We already have the dataset downloaded. That's why it says skipping found. So we'll just run these cells, and as I've always been saying, we are using Jupyter notebooks, which are very important in the data science field. So we are going to read the Olympics dataset, and remember we had said that there is structured data and there is semi-structured data, and we see here a CSV is an example of a semi-structured data. So like the data that you're going to read is a CSV file. We'll read it into a structured form of data. Basically, that's what we are going to do. We are going to move from this step to this step. This is the dataset that you're going to use, the Olympics dataset, and as you can see in our notebook, that these are 120 years of Olympic history, athletes and results. So this is a basic biodata on athletes and medal results from Athens 1896 to Rio 2016. And the reason why we are using this dataset is to give you a practical example when it comes to structured data and unstructured data types. So we'll read this file into our Jupyter notebook. We'll read this file into our Jupyter notebook. So as it reads the Olympics data frame. As we have already mentioned, that there are various types of variables and each captures different types of data. And importantly, the specific type of data influences the knowledge that can be derived from it, as well as what cannot be acquired. And therefore, it is essential to comprehend the different data types. So you may ask, why are we studying to understand the different data types, or what structured and unstructured and semi-structured data is? And we have answered that various types of variables will capture different types of data. And it is important to know the specific type of data, because knowing the specific type of data influences the knowledge that can be derived from it, because there is a knowledge that you can derive from structured data that you will not derive from unstructured data. There's a knowledge that you will derive from semi-structured data. So that's why it's important to understand these data types, so that you know what can be acquired and what cannot be acquired. So we have talked about structured data, and we'll delve more and define them. But this image from a big data framework can give you a clue that's structured data, and already you can see that structured data is arranged in form of rows and columns. It's not clear, but we'll give a clear image in this tutorial. Then this is unstructured data, considering what we have seen in our mind map, and it contains textual data, image file, videos, and audios. And this is an example of semi-structured data: XML data, JSON data, sensor data. Then there is also metadata. So structured data, unstructured data, and semi-structured data. And it's important to note, when you're talking about statistics for data analysis, it's important to know that the differentiation between quantitative and qualitative data represents the fundamental basis for categorizing data types. So whenever we talk about the data types, that the basic differentiation between quantitative and qualitative data represents the fundamental basis for categorizing data types. In short, what we are saying that there are two basic data types of structured data, which are numeric and categorical. But before we get into these basic data types, let us define what structured data is. So structured data, it refers to data. When talk about structured data, it refers to data that possesses a well-defined internal framework, and such data is meticulously organized and can be easily understood and interpreted. It is commonly stored in form of table formats. So when talk about structured data, it refers to data that possesses a well-defined internal framework, and such data is always meticulously organized, or is always organized and can be easily understood and interpreted. And already we have already said that it is commonly stored in table formats, and that's why we gave an example here, that structured data is always stored in form of rows and columns, or in tables, as we shall see. So it is commonly stored in table formats comprising rows and columns, with the data in each column sharing a consistent semantic significance. So that is structured data. So as a beginner data analyst, or as someone who is studying statistics for data analysis, already now you know what structured data is, so that whenever you meet you meet given data in your experience, or in your workplace, now you'll be able to know which kind of data it is. So the first type of data that you'll meet, or that you'll work with a lot, is structured data, and we have defined it. And basically, what is structured data? It is data that has been structured, and most often it is commonly stored in rows and columns. Then we also have unstructured data, and this refers to data that has no predetermined internal structure, thus existing independently from one another. And unstructured data encompasses various forms that cannot be stored within a structured database or format. Unstructured data encompasses various forms that cannot be stored within a structured database or format. Although it is essential to note that unstructured data may possess inherent structures, and these structures are not explicitly predefined. And examples of unstructured data, as we have given, include text files such as PDF and doc formats, as well as media file encompassing audio, videos, and images. And if we go back to our mind map, already you see how unstructured, what is unstructured data. You already see what is unstructured data. So that is unstructured data, and these are the common data that you'll be meeting, or you'll be working with: structured data, unstructured data, and semi-structured data. And when we talk about structured data, as we had mentioned, we had said that it is structured and it is commonly stored in table formats comprising rows and columns. This is an example of structured data. It is stored in a table format with columns and then rows. So in your practical experience, you will work with data that has got maybe 30 columns, 50 columns, hundreds of thousands of rows, depending on how huge or how small is the data. So basically, when we talk about structured data, this is an image of a structured data. So let us read this Olympics. Let us use a practical example and read this Olympics data. We already read it. So let us see the first 10 columns. Now this is we are using Pandas library, but even if you're not using Pandas library, at least as you had mentioned, that these core steps are very important, or this basic understanding is very important. So you can see that this Olympics data has been arranged into rows and columns. There is a column for name, sex, age, height, weight, team, games, year, season, and then there are rows. So these are practical example of a data set that has been arranged into structured data, or a data set that is, these are practical example of structured data that you will work with time and again in your practical experience. So we have read this data from Kaggle, and this is an example of structured data which has been arranged into rows and columns. And you can see this is what we are saying. It looks like the image that I've just shown you. So with structured data, as we have seen, it can be categorized into two basic types, which are numerical and categorical. It can be categorized into numerical and categorical. Let us go back to our mind map, and in this second node, we are talking about structured data, and it is divided into two basic data types, which are numerical and categorical, So structured data divided into numerical and categorical. So we go back to our notebook. So let us see the columns that we have in this Olympics data frame. Let us see all the columns that we have. So we see that these are the columns that we have. There's a column for ID, there's a column for name, there's a column for sex, age, height, weight. And already, as you can see, some of these columns are numerical, some of these columns are categorical. So another thing that you need to understand when you're talking about essential concepts for essential statistical concepts for data analysis is numerical and categorical columns. So you can take a wild guess, which one do you think is a numerical column here, and which one do you think is a categorical column before we define. ID, is it numerical or categorical? Name, is it numerical or categorical? What about sex? What about age? What about height? But don't worry if you do not get it, because that we are going to define that. So this is an example of data frame, structured data frame, which consists of columns and rows. So this Olympics data frame, it has these columns. These are the columns which are arranged vertically, and it has rows which are arranged horizontally. So let us get a concise summary of the data frame to explore the basic data types in the Olympics data frame. So already we can see that ID is an integer, name is an object, sex is an object, age is a float. A float is a decimal number in Python programming language. Height is a float, weight is a float, team is an object, then year is an integer, season is an object, and so on and so forth. So we'll seek to understand more of this, that out of this, which ones are numerical data types, and if sex, is it a numerical data type or is it a numerical data type or a categorical data type, and how do we know in a pandas data frame? Already at the end of this, you should be able to know that if it is an integer, is it numerical or categorical? If it is an object, is it numerical or categorical? So we have used we have read the Olympics data frame, but because we are not studying pandas, we'll not go much into this pandas code that we have read, we have used to summarize this data type. We have used to summarize this data frame. We are looking at essential statistical concepts, and today we are starting about structured and unstructured data. So we have just printed out the summary of the data frame to explore the basic data types in this Olympics data frame or in this pandas data frame. So also we can print a summary of columns count and these data types, but not per column information as we have seen. So to do that, you will pass in this parameter. You will pass in this parameter verbose. When it is false, this will be the output. But when you don't pass in this parameter, this is the output. So we had read it. We had read a concise summary of the data frame to explore the basic data types in a pandas data frame. And in this following line of code, we have printed a summary of the columns count and these data types, but not per column information as we have done in the previous cell. So we had said that the two basic data types are numerical and categorical. So what is numerical data? Numerical data, also quantitative data. Numerical data, also defined as quantitative data. And if you go back to our first tutorial on essential statistical concepts for data analysis, we had mentioned about this. We had mentioned about this when we were looking at data types. We said that they are divided into two broad categories, which are quantitative, which is numerical data type, and qualitative, which is categorical data type. So when we talk about structured and unstructured data, is that structured data, because now we are looking at structured data, is divided into two basic categories, which are numerical data types and categorical data types, or quantitative data type and qualitative data type. We had mentioned this, and already if you see this structure, this mind map that we are using today, numerical and categorical. And from our last tutorial, we had seen that numerical is quantitative and categorical is qualitative. So basically that is what we are saying here. So numerical, which we have said, is also quantitative data. Quantitative data, or quantitative data, also known as numerical data, is recorded as numbers and serves as an objective measure or count. And it encompasses various factors as temperature, weight, and the number of transactions. Now, let us give now a practical example. We have already seen that there is numerical data, there is categorical data. Now, we were working with the Olympics data frame. Now, how will you know out of these columns, how will you select numerical data types and numerical columns and categorical columns? Now you have been given a data set like this Olympics data set, and you have been told that out of this data set we want you to extract numerical data. How will you do that? So because you're not studying pandas, so quickly we'll just give this the line of code that you'll use. You are trying to get numeric columns only. So we are trying to get numeric columns only. So this is the line of code that you will write. So you go and find out. You go and find out, because we know that there's a lot of finding out that you'll have to do when you are in the data analysis field. So to get numeric columns only, you take this is the line of code that you will write. So let us see the first 10 rows of numeric columns only. So these are the first 10 rows of numeric columns only, and already we have seen that these lines of code, they give us the numeric columns only. So we have printed them. It has been captured as, this line of code has captured them as numeric columns. So we have seen that there is numeric data types. That one we have seen, which is very important. Another thing that is essential to note is that numeric data can also be classified into two types. Numeric data types can also be classified into two types. Numeric data type can also be classified into two types. So we now move to numeric. We break it further, that there is continuous and there is discrete. So we have structured data, which is divided into numerical and categorical data types, and numerical or quantitative data is categorized into continuous and discrete. It's categorized into continuous and discrete. So that is very important to note. That is very important to note. So what is continuous? When we talk about continuous data is data that can take on any value within a given range, such as wind speed or time duration. And we see that wind speed can take any value, be it a whole value, or be it a decimal value, or be it a float, and time duration also. And we'll see these, we'll understand this further. So continuous data again can be divided further. So when talking about data types, continuous data can be divided further into two types based on the scales of measurement used for their measurement. So numerical data type can be divided into continuous data. As we have seen, numerical data types, it can be divided into two types. The first one is continuous, and we have said continuous data is data that can take on any value within a given range, such as wind speed or time duration. And again, continuous data can be divided into two types based on this on the scales of measurement used for their measurement. For example, there are interval scales. And when we talk about interval scales, these are scales that lack a zero measurement, as in the case of the Celsius scale, which does not indicate the absence of temperature despite having zero measure. This absence of a true 0 point can be significant when interpreting statistical data. So basically what we are saying is that continuous data can be divided into two interval scales, and we have given an example of what interval scales is. Again, it can be divided into ratio scales. And talk about ratio scales, these scales possess a measurement of 0, which signifies the absence of a particular property. And to illustrate, 0 kilograms indicates the absence of weight. Like if you have 0 kilograms of we can say 0 kilograms of sugar, and it indicates the absence of weight. As a result, measurement ratios hold significant for these scales. For instance, 30 kg is 3 times the weight of 10 kg. Again, continuous variables allow for the assessment of various properties, including but not limited to mean, median, distribution, range, and standard deviation. And these measurements provide valuable insights into the characteristics of the data. Now, the second type of numerical data, we have seen that the first type is continuous data. The second type is discrete data. And as we have already mentioned that continuous data, we have already mentioned about continuous data that they can be meaningfully divided into smaller increments, including fractional and decimal values. For example, height and weight and already we have seen that continuous data can again be divided into interval scales and ratio scales. And now we are looking at discrete data. So numerical data, continuous data, and discrete data. And discrete data, an example of discrete data is number of children or number of pets. Now, what does that mean? What does that mean? What does that mean? Let us go back to our notebook. That discrete, when talk about discrete data type or discrete data is data that can take on any certain value, such as the count of the occurrence of an event. That discrete data is data that can only take on certain values. Can you note the difference between discrete and continuous data? We said continuous data. Continuous data is data that can take on any value within a given range, including decimal points. But what about discrete data? We have said discrete data is data that can only take on certain values, such as the count of the occurrence of an event. An example is the number of children. We can only say that someone has 1 child, 2 children, 3 children, 4 children, and we cannot say that someone has 1.2 children or 4.5 children. Now, do you see the difference between discrete and continuous data? And you'll see the importance of all this by the end of this tutorial, why it is important that when you are working with data types, why it is important to understand structured data, to understand the types of structured data, to understand that there's numerical, there's categorical, to understand the importance of to understand that numerical can also be divided further into continuous and discrete. Again, it's essential to note that when talk about this discrete data is that these counts are non-negative whole numbers that cannot be further divided into smaller increments. But continuous data, when talk about continuous data in essential statistical concepts, is that continuous data can further be divided into smaller increments. Now, when dealing with discrete variables or discrete data types, it is possible to compute and evaluate the frequency or a summary of the count, such as the mean, sum, and standard deviation. As an illustration, we can say that in the year 2014, the average number of vehicles in US household was 2. But despite that, nevertheless, certain numerical variables like area codes are not classified as quantitative variables since they lack variability in quality. That's why I asked you, in as much as we are talking about numerical data, do you think year has variability? Do you think this ID, it has variability? That's another assignment. You can go and find out. But as you go on to find out on the same, we have seen that certain numerical variables like area codes are not classified as quantitative variables since they lacked variability in quality. For example, a bank may be concerned with determining the average loan size provided to its customers, but calculating an average area code will be nonsensical. And that's why I've asked, do you think it will be sensical to calculate the average, to calculate the average ID, to calculate the average year? Is it sensical or nonsensical? Now, again, another important to note when talking about a structured and unstructured data, and now we have moved to structured data, is that when examining quantitative variables, it is essential when examining quantitative variables, it is essential, when examining quantitative variables, it is essential to focus on two significant aspects: the central tendency and the variability. And we'll be looking at this in upcoming tutorials, often referred to as spread of the data. For example, one might inquire about the average annual precipitation and the extent of variation observed from year to year. We'll dig more into deep when we'll dig deeper into this when we'll be looking at central tendencies and variability in our upcoming tutorial. So basically that is it about numerical data. To make it easier, we have a mind map here that will help you understand it, that has broken down easily. Next is that structured data is also is divided into numerical and categorical, and next is categorical. When we talk about categorical data, it is divided into fixed set of values, binary data, and ordinal data. Categorical data is divided into fixed set of values, binary data, and ordinal data. When we talk about fixed set of value, these, for example, we can say type of residence. We can say type of residence. Type of residence, for example, you get a column that has residence. Now, the type of residence can be a house, can be a condominium, can be an apartment, can be a dormitory, or can be other. So this is an example of categorical data that has fixed set of values. Then there is binary data. For example, there is binary data. An example of this is yes or no, true or false. Then there is ordinal data, and you have seen statistical questions that come with gradings. For example, poor to excellent, with agreements, strongly agree to strongly disagree, or strongly disagree to strongly agree, and ranks. For example, sporting teams. For example, sporting teams. So when we talk about categorical data, what we mean is that a variable is referred to as categorical when each observation is assigned to one of a predefined set of categories. Categorical data. What is categorical data? Categorical data is when each observation is assigned to one of a predefined set of categories. Let us give an example. Gender is divided into two categories, male and female. Religious affiliation encompasses various categories including Catholic, Jewish, Muslim, Protestants, other, and none. So, like when you come to gender, male is a category, female is a category. So if you have a column with gender, it will have two categories, male and female. If there is a column for religion, it will have various categories like Catholic, Jewish, Muslim, Protestants, other, and none. So that is an example of categorical data, and we are seeing how its observations are assigned to one or predefined category. So when you are working with a data set, you need to know if it's a categorical column or not a categorical column. Again, when dealing with categorical variables, it is crucial to analyze the number of observations across different categories. And one essential aspect to consider is the proportion or percentage of individuals falling into each category. Like you need to know how many individuals fall into this category or how many observations fall into this category. For instance, one might be interested in determining the percentage of students who identify as Democrats within a particular college, or the percentage of students who identify as Republicans within a particular college. So that is very important. We had seen how to get numerical columns when you're working with a pandas data frame. And again, when you're working with a pandas data frame, how can you get categorical columns only? So you will use this line of code. These in our Olympics data frame, we want to get the categorical columns only. So we'll use the select dtypes method, and we'll pass in this parameter. We'll pass in this parameter include np.object. Remember, when you are selecting numerical columns, we used the select dtypes method, but the parameter was np.number. So already we have seen that for numerical columns, they are numbers. For categorical columns, they are objects. And we go back here. So already from this summary, you can tell which columns are numeric and which columns are objects, which columns are numeric and which columns are object. And that's why it's important to understand structured and unstructured data, because when you understand structured data, you will know how it is broken down further. And from this summary alone, if you're working on this data set, you will be able to know which one is numeric and which column is numeric and which column is categorical. So that is very important. That is very important. So on categorical data, we have seen how we can select categorical columns. Let us run this cell and get the first 10 rows of categorical columns. So already you see name is under categorical, sex is under categorical, team is under categorical, games is under categorical, season is under categorical, city is under categorical, sports is under categorical. When you will be working on this example, go to Kaggle and try to find out what is NOC. What is NOC? Try to find out what is NOC. That's a very simple and basic assignment. And the reason why I'm giving you this simple assignment so that you can be used to finding out things or Googling your way out, because that is another important skill that you need to have as a data analyst. So lastly is that when we have structured data, we'll always need to visualize structured data, and it's important to take note of this. But later in these tutorials, we'll look at visualization of visualization. But please note that histograms are a highly effective method for visually representing continuous variables. So when you know that you have continuous variables, one highly effective method for visually representing them is using histograms. Then scatter plots serve as an excellent tool for visually representing the connection between two continuous variables. Then bar charts are a commonly used method for visually representing discrete variables, but we'll not get deep into this because we'll be looking at visualization in our upcoming tutorial. So basically, for further reading, these are very important resources: Embeddings, Practical Statistics for Data Scientists by Andrew Bruce and Peter Gedeck, and Introduction to Statistics, an Intuitive Guide by Jim Faust, and of course, and as always, Pandas documentation. So go and check at these references that we have given here. Very, very, very important. So what we have done is that we have been able to download the Olympics dataset, which we have utilized to provide practical code examples. We have defined structured and unstructured data. We have delved further into the fundamental classifications of structured data, namely numerical and categorical, and broken them down even further. And we have looked at the preferred methods for visualizing structured data. So you can go to my GitHub page. And you will find a well-written notebook. You will find a well-written notebook that will help you in your revision. There is a notebook that I have in my GitHub page. You can find all the notes that we have used for this tutorial. There is this documentation. It's very important. You can use it, and also you will find this notebook in our GitHub repository so that to help you revise. So that has been our tutorial on structured and unstructured data. So thank you for joining us on this insightful tutorial on essential statistical concepts for data analysis, whereby we have looked at structured, unstructured, and semi-structured, but we have narrowed down to structured data. And we hope you have gained valuable knowledge and skills to analyze both structured and unstructured data. So don't forget to like, subscribe, and hit the notification bell to stay updated on our upcoming tutorials. So keep exploring and unlocking the power of data. See you next time. You have a blessed day.